Anyone want to make a guess? So we have tension ultimate, tension in yield, shear in yield. Okay, Young's models we know. Okay, fine, Young's models. But which one will you use? They also have what? Ultimate strength in compression. Ooh, right? Right? But which one will you use?
One of the ones in yield strength.
I like that. Okay. You know, when I was young, again, I did not know this until I was working for Rolls Royce. That is means I finished my PhD already. Okay, sorry, I was doing my PhD and working Rolls Royce at the same time. I'm like, and you know when when I work in a foreign country, I'm not the native people. I don't tend to ask because I feel embarrassed. Okay, I want to keep up a proper image. So when you do ask, they will say, "Haven't you been taught?" Right? Okay, and the person that say that haven't you been taught also have no freaking clue. By the way, right? Okay. First of all, why do they give us two values about ultimate strength and ultimate use strength? Anyone? Why do they give those two values? So you guys have done, most of you have done manufacturing with me. So this is yield. This is ultimate strength. So which one will you use? Anyone? Do you use ultimate or do you use yield?
It depends, doesn't it?
Yeah, right. It depends. And Miriam, you say yield. Okay, right. Ultimate strength comes before you. Okay, ultimate tensile strength. Mira, you don't need to say UTS. You just say ultimate strength. As you can see, the ultimate can be in tension or compression. So in ultimate strength, just say ultimate strength. Okay. Now, in the textbook, the factor of safety, okay, is equal to is equal to uh is equal to this is allowable divided by UTS. Okay. Do you have any or US? Okay, not let's not go to US. Let's go in ultimate tensile strength. Okay. So Nathan say if we exceed the U strength, then won't the beam be exactly okay? Uh, Nathan, that's exactly the point. So if you refer to the textbook, okay, if we were to refer to the textbook, where is the textbook? Again, guilty conscious. And this is, I think Dr. Koshi do cover this, okay, and he's not wrong, okay, but there's I have issue with that, and I'll tell you what's the issue. And Nathan brought that up already, okay. And Roseanne has a point of view there also. Wait, so if you look at the textbook, where is it? Oh, I got it the other way. Ultimate over. So you can see here it's ultimate load or ultimate strength divided by allowable. Sorry, I got it the other way. Now I'm embarrassed now. Okay, so I got it the other way. No, allowable, no, ultimate strength, yeah, is always greater than 1, sorry. So that's where Nathan is right. When it exceeds the U, it will. But you see from the textbook, right? When you look at the textbook, it said what? When we look at the textbook, it's also ultimate load means ultimate strength. Okay, so if it's not ultimate, okay, by right we don't want the material to reach the yield. Yes or no? Right? If we go beyond the yield, what will happen is plastically deformed. Okay, so I believe Nathan will say Eugene, right? Nathan, tell me if I'm right or wrong. Shouldn't this be the right way of doing it? right? Nathan, am I right?
I guess in theory, yes.
Yeah. And you know what? This is what this degree is all about. Okay. I will tell you this. Okay. Both ultimate strength and use strength are correct. But when to use what? Okay. So for this case, when you use ultimate strength, is for brittle material. Aye. Brittle material like concrete, glass. I can't spell again. Glass, okay, ceramics, anything that is brittle. Okay. This one you use for ductile material. So it's like your steel, aluminum, right? Anyone know why? I just told you that, okay, brittle material, you use ultimate strength. Ductile material, you use steel. Anyone?
Is it because, oh, sorry, go ahead.
Yes.
Okay, I was just going to say it's because there isn't much strain between the UTS and the yield strength for the brittle materials. So it doesn't matter as much because they won't expand as much.
Who are you?
Jasmine.
Jasmine, you got it spot on.
Oh, sweet.
Okay. And I'll draw what Jasmine says. I'll draw what Jasmine says. Did I teach this in strength or in manufacturing? No, right? I did
I
not
don't
mention.
think so.
Yeah, I don't think so. I can't
Yeah.
remember also. So what Jasmine says, this is for brittle material. It goes straight and then it fracture. Okay. So this is your yield for brittle, your ultimate for brittle. Okay. So what you see from here is the yield for brittle is very similar to your yield to your ultimate for brittle material. Okay, so over here, this is for brittle. If there's a change, it's gonna be a very small change. Okay, so this is where you use the factor of safety is equal to stress UTS divided by stress allowable. So that is for brittle material. So brittle. For ductile material, you don't see that. So the Young's modulus is lower. That's why the curve is less. And then it does this. Right. So this is where your yield is. So this is your stress yield ductile. Over here, this is your stress ultimate ductile. Okay. So from here you can see that the stress yield ductile is smaller than the stress ultimate ductile. Okay. So for this case, your factor of safety is going to stress yield, okay, divided by stress allowable. Right. So this is ductile. So a degree is at a bachelor level is not, in fact, a lot of students don't know this. Okay, I know it. I don't know why I should not share it. Okay, so that is why, okay, depend on the material that has been loaded. If it's ductile, you use yield. If it's brittle, you use ultimate. Are we clear? And it's not rocket science at all. Okay, it all goes back to fundamental known as what? Stress strain curve. That's it. Okay, it's not like, oh, this is going to be very no, 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 no. You guys have seen me teach you guys 3CO3 before. It all goes back to what? Fundamental. Okay, more important than anything else. Okay. Okay. Any other questions before I let you go? Anyone? Okay, so if not, okay, those who are taking heat transfer today, and some of you have term test tomorrow, all the best. Okay, I think Dr. Judd will be more gentle to you guys who are taking heat transfer, because the class average is bloody higher than mine, which I'm so envious. So the term test will be the same thing. Okay, you go to Avenue to Learn, Samia Avenue to Learn. I will give you guys 45 minutes to scan, upload, share information, whatever. Okay, and what else? That's all I have. Okay, and yeah, go out for a beer tonight. Okay, you guys need it. Look at the weather. Okay, any other questions, please? No, if not, I will see you guys online on Monday. Thank you. I'll see you guys. Bye.
Thank you, Professor. Take care.
Thanks, Professor, for all the help today. Have a good weekend. I'll see you on Monday.